Welcome back to Chapter 1. Our final section, 1.9, covers implication, equivalence, and logical independence. So let's begin with logical implication. And we're going to start with our example based on number. 100 implies 10. So if you have 100 horses, that implies that you have 10. 10 implies 1. If you have 10 marbles, that implies you have 1 marble. All implies some. If I have all the gold in the world, then I have some of the gold in the world. And some implies 1. If I have some apples, that implies I have 1 apple. Now, does 10 imply 100? If I have 10 feet, does that imply I have 100 feet? No. Does 1 imply 10? If I have 1 hot dog, does that mean I have 10 hot dogs? Nah. Does some imply all? If I have some money, does that mean I have all of the money? No. These don't work. Does 1 imply some? Well, this is a really interesting question. You could think about it, maybe bring it up in class. 10, however, is implied by 100. 1 is implied by 10, and some is implied by all. 1 is implied by some. All right, so we looked at logical implication by number. Now let's look at it by context. This is Tommy. Now, if Tommy is in the bathroom, that implies that Tommy's in the house. However, if Tommy goes in the house, does that imply that he's in the bathroom? No, we have no way of knowing where Tommy is inside the house. Let's try another example. This is Marie, and she is in Bakersfield. And being in Bakersfield implies that you're in California. And being in California implies that you're in the US. And being in the US implies that you're on the Earth. However, if Marie were on the Earth, would that imply that she's in the US? Nope. Just because Marie's on the Earth doesn't mean we have any idea where on Earth she is. So be careful in how you work with this. Now just some general logical implication. If all roses are red, then some roses are red. If no men are reptiles, then some men are not reptiles. If I am poor and hungry, then I am poor. It also implies I am hungry. So hopefully you are beginning to understand how logical implication works. So let's move on to equivalence. Two statements are logically equivalent when they imply each other. You are already familiar with equivalence because of less. Everything on less, numbers 1 through 22, are all equivalent to each other, as well as being equivalent to a standard form conditional. So let's look at a few. We're not going both to the ballet and the symphony is logically equivalent to either we are not going to the ballet or we are not going to the symphony. You can see the shorthand here shows the logical equivalence. These two statements have the same meaning and the same truth value. Let's try a few more. It is not the case that I am not 25 years old. This statement is equivalent to I am 25 years old. Do you see why it's equivalent? There is a double negation, and a double negative becomes a positive. So these two statements are logically equivalent. Same meaning, same truth value. And finally, we'll take a look at logical independence. Two statements are logically independent when they are not logically related. So for example, today is Friday. Sodium chloride is the technical name for salt. These two statements are logically independent. They don't have a relationship to each other. So let's review. Contradictories can't both be true, nor both be false. Remember, they have opposite truth values. Contraries, on the other hand, can't both be true, but they can both be false. So if one is false, we don't know anything about the other. Two statements can both be true at the same time, and these are consistent. Two inconsistent statements can never both be true. Thus, all contradictories and contraries are inconsistent. They can't both be true. And all inconsistent statements are either contradictories or contraries. A statement P implies a statement Q if and only if whenever P is true, then Q is true. So, if I have 100 horses, P, then it's true that I have 10 horses, Q. Statement P, I have 100 horses, implies statement Q, I have 10 horses. Two statements are logically equivalent when they imply each other. So remember, logically equivalent means same meaning, same truth value. And finally, two statements are logically independent when they have none of the above relations, and their negations have none of the above relations. They just are not related to each other. They are logically independent. So the skills we were hoping you would find in this section is to recognize and become familiar with the statement relations. We also want you to make inferences to the truth or falsehood of statements from the truth or falsehood of logically related statements. And finally, to learn to recognize logically equivalent statements. So let's take a look at the homework. A asks us to write a statement that implies the given statement. So the given statement is all students have books. And what we need to know is what, if it were true, would imply that all students have books. And there's many statements that will work. All people have books, all humans have books, all students have books and pens. If any one of these statements are true, then it would imply that all students have books. Because if all people have them, then all students have them. If all humans have them, all students have them. And if all students have books and pens, then all students have books. For B, they want a statement that is implied by the given statement. So if all students have books, what does that imply? Well, if all students have them, then some students have them. And finally, C wants a statement that is logically equivalent. And remember, logically equivalent means same meaning, same truth value. So we could be a little cheeky and once again do the double negative. It's not the case that all students do not have books. Double negative becomes a positive, so we have a logically equivalent statement here. Or we could reword it, books are had by all students. However, you might catch that this is a hidden conditional, so it's also logically equivalent to all of the statements listed on less. We take a look at less and he shows us, oh, there it is, number 6, all P are Q. So, If you are a student, then you have a book is also logically equivalent to all students have books. So to recap for homework 1.9, A implies the given statement. B is implied by the given statement. C is equivalent to the given statement. And how it works is that if A is true, then the given statement is true. And if the given statement is true, then B is true. And the given statement has the same meaning and the same truth value as C. So if the given statement is, I ate 25 eggs, what if it were true would make that true? Well, if I ate 50 eggs, so A could be, I ate 50 eggs. And that would make the given statement, I ate 25 eggs, true. B asks, if the given statement, I ate 25 eggs, is true, then what does that guarantee to be true? And it guarantees any number less than 25. I ate 24 eggs, I ate 23, and so on. And for C, we need a statement with the same meaning and the same truth value. So what's another way of saying I ate 25 eggs? 25 eggs were eaten by me. Eat 25 eggs, I did. However, you can find the logical equivalence. It will work. Good luck on your homework, and if you have any questions, email me.